You know how your AI sometimes takes forever to spit out an answer? Like you can literally go make coffee, come back, and it's still generating? Well, what if I told you there's a way to make it run 85% faster right now without changing the model, without buying better hardware, and without selling a kidney for more GPU memory? Here's why LLMs are slow. Every time you ask a model to generate text, it has to run a full forward pass for each token. That's each individual word fragment, one token at a time through 100 billion parameters. It's like sending the entire Senate to read once the model costs you modus, then calling them back for the next sentence from a book, then calling them back for the next sentence. And the next. DeepSeek v4 has 671 billion parameters total for every single token. So when you see that cursor blinking and nothing happening, that's not bad internet. That's the physics of what's happening inside the chip. Each full pass through that monster module costs you time, electricity, and your patience. Now speculative decoding isn't magic. It's actually kind of dumb in a clever way. Imagine you're a CEO who has to personally review every single word in every single email your company sends out. That's your big model right now. Now imagine you hire a junior assistant who drafts the emails for you and you just check them. If the draft is good, you sign off. If it's bad, you rewrite it. The speculative coding. So DeepSpec isn't a model. It's a tool for making the draft models, a complete training pipeline with data prep, model training, evaluation scripts, the whole factory. Think of it as the instruction manual and assembly line for building your own speculative decoding system, not the car itself. Does code that works. DeepSeek open sourced the exact code they use in production to train draft models that accelerate their live systems by 60 to 85%. And they slapped an MIT license on it, which means anyone can use it, modify it, resell it, whatever. No strings, no contact sales, no scheduler demo. DeepSpec comes with 3 different drafting strategies because one size doesn't fit all. First is DSpark, the new kid, DeepSeek's own paper, semi-autoregressive architecture with confidence scheduled verification. That's the star player giving 60 to 85% speed up on DeepSeek v4. Second is DFlash, a parallel drafter that generates a whole batch at once, like having multiple assistants each draft a different paragraph simultaneously. Third is Eagle 3, an efficient autoregressive draft model that's more conservative but more reliable. 3 tools in a shed. DSpark is the power drill. DFlash is the circular saw. Eagle 3 is the hammer. The repo gives you all 3, plus training code, plus evaluation across GSM 8K, Mage Human Evil, MBBP, MT Bench, the whole laundry list. Let's talk raw numbers, because that's what matters. On live DeepSeek v4 traffic handling, real user requests, DSpark delivers 60 to 85% faster generation at the same throughput. That means if your model takes 10 seconds to respond, now it takes 2 to 4 seconds. Users wait less, you serve more requests on the same hardware, everyone wins. The paper describes this as shifting the Pareto frontier of our serving system. Researchers speak for, we made the impossible possible. Here's what's actually exciting. You train one draft model and it works with any Hugging Face compatible base model. So you pay the training cost once and you get the speed up forever. Every inference call, every API request, all faster and cheaper. And because the draft model is tiny compared to the main model, 4 billion parameters versus 71 billion. Running it alongside the big one adds almost no overhead. It's like stuffing a smart car in the trunk of a semi-truck. Extra weight? What extra weight? What weight? Alright, let's pop the hood on DSpark because it's genuinely clever. Traditional speculative decoding works sequentially, draft a token, verify it, repeat. DSpark drafts multiple tokens at once using a semi-autoregressive architecture, blocks of 7 at a time in its default config. The big model checks the whole block in one shot. But the really smart part is confidence scheduling. Each token gets a confidence score. High confidence tokens get batch approved without individual verification. Low confidence tokens get flagged for careful inspection. It's like airport security. Grandma in sandals gets waved through, trenchcoat guy gets every pocket checked. This selective verification is what pushes DSpark past simpler decoders. And the results hold across GSM 8K, Match AMI EH, AMI EVALI, Live Code Bench, and more. Now, the bad news. And there's always bad news. Data preparation for DeepSpec requires approximately 38 terabytes of cache for the target model. That's not a typo, 38 terabytes. You're going to need storage, and training assumes you have at least 8 GPUs. This is not a pip install and go situation. This is a production infrastructure. You need a cluster, you need the data pipeline, you need the cooling bill. DeepSpec is designed for companies running LLMs at scale. But here's the thing, until today, so here's the takeaway. DeepSpec is the first time a major AI lab has open sourced its production, speculative decoding training pipeline. It takes an idea that was mostly academic, training draft models, and turns it into a battle-tested, MIT licensed code base you can actually use. 3 algorithms cover different speed. Reliability trade-offs. The benchmarks are solid. The 60 to 85% numbers come from live traffic, not synthetic benchmarks. Yes, you need 38 terabytes of storage and enough GPUs to make a crypto miner jealous. But the barrier just dropped from build it yourself from scratch to clone the repo and run the training script. That shift in the Pareto frontier is real, it's measurable, and it's free. If you're running inference at scale decoding,